Right. Okay. Hopefully this is going to work okay for Sven to understand. Hard part with this question is sorting out what's happening and when. There's two time zones we're talking about. So let's set up the initial picture with t is 0. Time 0, two balls are both projected upwards. Now, one of them is from the ground, that's particle B, and particle A, they say, is 50 metres above. So this one has a gap, 50 metres. Oops, sorry. Just getting towards a funny place on my tablet. So S0 is 50 metres, particle A. Projected up with a velocity UA is 2 metres per second. So that's an equals, not a 2. Okay. And it's falling under gravity. I'm going to assume positive direction is upwards for all my equations. So in all my equations, G is actually a negative G. Particle B starts on the ground and is projected upwards with a velocity of 20 metres per second, and again has an acceleration of G downwards. Okay. Now that can actually lead us to two equations straight away for that one. The second situation is a relatively trivial situation where T have got to some height H, so the height of S for A and the height of B, and we're going to be calculating an SA and an SB. That height is the same for both of them. So we've got A and B. Some height above the ground. The one important thing with this is we have not necessarily got to the top of the arc. We don't know if they're going to still be moving up. That could still be moving upwards, that could be moving down. Actually no, because that started below. That could be moving down, that could be moving upwards. Or they could now both be reaching the apex. We don't know, but according to this, we reckon that there's going to be a situation where there's one or two solutions. But this one's relatively trivial. So the hard part is A. Let's have a look at B first though. So we can do the height of B, and I'm going to stick to using S as being displacement. We've got a displacement starting with 0, and it goes up with an initial velocity of UB. So let's think about suvat. We know an S, or that's what we want to work out. U we know. V we don't know. It is not, that's the point about this one, is we do not know, it's not an apex. At apex we would know that would be 0, we don't know it. A we know is minus G, and T is the value 2 we've got to work out as well. So let's write this equation for B. S U T A, that's S equals U T add on a half AT squared formula. That's the one we're going to need. So that S is going to be 20 T minus a half of G is minus 4.9 T squared. Okay. So that's where this is a minus a half G, saying that G is acting downwards against the direction of travel. Then we have to do the same thing for A. So SA is equal to, and it's the same thing, initial velocity 2t minus 4.9 t squared, because it's still acting under gravity in the same way, it's still following this same formula. But the difference here is there's actually an additional displacement of 50 meters. So this displacement part of this formula is a displacement from the beginning, and by putting this 50 in, we're now saying displacement from the ground in both cases. Okay, so now we're at the point where we can actually bring these equations together. So when t equals t, we actually get to the point where SA equals SB equals our height h. So SA 2t minus 4.9, or capital T it should be, 4.9t squared plus 50, because it starts 50 metres above, and 20t because it's travelling faster for part B, but still suffers the same deceleration. Nice thing to see with this is because the t squareds will cancel. So what we wind up with is 2t plus 50 is equal to 20t. Now I rearrange and we get 18t is 50. Do the cancel the division and you get, where's my calculator gone? It's 2.7 recurring seconds, which I think was the answer to part A we wanted. So part A was time, yeah, and part B, the height, we can use either of the formulae we got above, so that the height is going to be one of these two calculations. I'll probably take that one. 20 times 2.7 recurring, use a memory in the calculator, minus 4.9 times 2.7 recurring squared. And if I use that, so I'm going to store my answer into a variable, and I might as well call it variable f. F is my time. So I've got 20 times f times the time. F is the memory location. Minus 4.9 half of g times my memory squared. And the final answer to that one is 17.74. We'll make it. Seven, 4, 6, 9, which to three significant figures is 17.7 meters. I'll just have a quick look at the answers. Give me a moment while I pause. Pause. Where's the balls? Okay. I think I've got it handy. Yeah, got it handy now. Approximates to 2.8 or better. Correct answer. 7.74 ... 7. And that value. And that's the solution. The key to it was being able to integrate it involve this 50 meters in the displacement equations. The actual displacements, Suvat analysis. We want height, the displacement. We know U. We know nothing about V because it's not going through the apex. We know the T is common across both equations, so we do sort of know a T. So we can put all our variables in, and then we do the same one on this side. S, U, V, A, T. S, again, is something we want to know. U is 2 meters per second. V, no idea. A is minus G, and capital is T. Okay. So now, hopefully that's cleared it up.